Hey class, in today's lesson we're going to talk about logarithmic functions and their graphs, which is found in section 3.2 part 2. Our objective is simply to graph logarithmic functions. So here we go. To graph y equals log base a of x, you can use the fact that the graphs of inverses are reflections of each other in the line y equals x. So what we're going to first do is review finding inverses. So as a reminder, if I wanted to find the inverse of y equals x plus 2, okay, then to find that inverse, we would switch x and y, so switch those variables, and now we have x equals y plus 2, and then we would solve for y. So if I subtract 2, I now have y equals x minus 2, and specifically, it's the inverse, so we call it the inverse of y is equal to x minus 2, and the way we show that notation for the inverse of y is it looks like y to the negative first power, okay? So this would be the inverse. On the next screen, we're going to do a couple of examples of how we would do inverses for log, but before we do that, I'm going to give you one more. So now that we're talking about log, if I have y equals log base 3 of x, to find the inverse of that, we first need to change it to exponential form. So remember, if I say log is bay, it's the base, this is the answer, this is the exponent. Excuse me, this is the exponent, this is the answer. Let me erase that so we can see that a little better. Okay. This is the exponent, this is the answer. If I switch it, I would have 3 to the y equals x. Okay, that's the exponential form of it. Now, as we know with inverses, we're going to switch x and y around. So now this becomes 3 to the x equals y. And so this is already solved for y, so that is its inverse. Again, on the next screen, we're going to practice changing some log functions to their inverse. So let's take a look. So the two problems that we're going to look at y equals log base 4 of x plus 1. And then we also want to look at y equals negative log base 2 of x minus 1 and then plus 3. That second one is a doozy, but we can do this one. So to do the first one, again, you want to switch it to exponential form. So remember, this is the base. This is technically the exponent. This is the answer. So we would have 4 to the y equals x plus 1. Okay. From there, we would switch x and y. So that becomes 4 to the x equals y plus 1. And again, solve for y. So we would get the inverse as being 4 to the x minus 1. Okay. On the second one, again, we want to change this to, well, actually, before we even change it to exponential form, we actually only want log and a positive log at that on the right-hand side. So I actually want to subtract 3 first, which gives me y minus 3 equal to negative log base 2 of x minus 1. And then I want to divide by negative 1 because, again, I want a positive log. So this would give me negative y plus 3 equal to log base 2 of x minus 1. Now that I have that, again, this is the base, this is the exponent technically, and this is my answer. So we will have 2 to the negative y plus 3 equal to x minus 1. Okay, again, we're going to switch x and y, so that now becomes 2 to the negative x plus 3 equal to y minus 1, and finally we add 1 to both sides. So we will get that y equals 2 to the negative x plus 3 plus 1. That's a plus 1. Okay, so that would be the inverse for that one. It looks pretty bad, but it's pretty doable. Okay, so now we're actually going to graph. So let's take a look at our next problem. So in example 4, it says in the same coordinate plane, we want to sketch the graph of each function. So we have f of x equals 2 to the x, and we also have g of x equal to log base 2 of x. So first, to do 2 to the x power, And I know I'm using kind of like a lower part. Actually, let me switch this. We're going to do x, and then its answer obviously would be f of x. So I'm just going to use -2, -1, 0, 1, and 2. If I sub -2 in here, that'd be 2 to the -2nd power, which is really 1 over 2 squared, which becomes 1/4, okay? So following that same pattern, my answers would be 1/2, 1, 2, and 4. All right. To get g of x, we actually just do it the opposite, right? Because the exponential version and the log version are inverses of one another by nature. So if I switch this up, now I have x and g of x. X and g of x. And I just use the values that are the inverse of that. So I would have 1/4 and -2. 1/4, 1/2, 1, 2, and 4. And then -2, -1, 0, 1, and 2. So if we were to graph this, all right, the first order pair is at -2 and 1/4, which is barely off the line. Then -1 1/2, 0, 1, 1, 2, and then 2, 4. Okay, so that graph is going to go like that. Its inverse, which is log base 2 of x. And again, the only way that we can ever technically graph log is if we find its exponential form first and then inverse it. So I would have 1/4 and -2, so just barely off the line. 1/2 and -1, which is about here. Then I have 1, 0, 2, 1, and then 4, 2. Okay, that graph takes on this shape here, and it really shouldn't have crossed over the y-axis. I just got a little lazy. And as a reminder, they are inverses because they are reflected about the y equals x line, right? It's a reflection of that line. So we are done. Okay, let's try the next problem. It says, using a calculator to find the output values, graph f of x equals log base 10 of x, then choose 5x values, state the domain, range, and the x-intercepts. So let's start. Again, we want to start with x and y. Okay, I always want to do -2, -1, 0, 1, and 2. Those are pretty customary numbers to use. And then its output is to y equals 10 to the x. And again, I'm using that because if I do log x bay and I switch this logarithmic form to exponential form, I'd have 10 to the x equals f of x. And for us, that f of x is the same thing as y, which is why you now see it over here. Okay, so if I sub in -2, I will get 1/100th, and then 1/10, 1, 10, and 100. To actually, and that's the exponential form, and then to graph the actual logarithmic form, then we just switch it around, right? So we're going to switch them around, and we will have now x and log base 10 of x as 1/100th and then -2, 1/10 and -1, 1 and 0, 10 and 1, and then 102. Okay, I'm barely going to be able to graph any of this because my graph is just way too zoomed in, but it's okay. I'm just going to do the best I can. So 1/100th and -2, again, is just barely off the line. 1/10 and -1 is also just barely off the one line. And then I have 1, 0, and then 10, 1 would be way down here somewhere, but either way, that sketch would be something like that, okay? So to answer our question, to state the domain, our domain, remember it's from left and right for domain. So our domain our domain, and I'm going to use interval notation, but you can use set notation if you want. But interval notation would give us parentheses 0 to positive infinity. Okay, our range would be from negative infinity. Negative infinity to positive infinity, because it is all real numbers. And then the x-intercept is going to cross our x-axis in one location, which is right here, and that is 1, 0. All right, so we are done with try number 4. All right, in example 6, all we're doing is we're just describing the transformation. So if you look at the bold line, it is a transformation of the lighter line. So all we're trying to do is say how it is shifted. If you look pretty closely, it's pretty obvious to see that the graph has been shifted to the right by 1 unit, right? Because it goes from 1, 0 to 2, 0. So shifted right 1 unit. That's it. That's all we're doing is stating the transformation. In example 6, we can tell, even the arrows are showing us that it's been shifted up. And again, if we look this time at the y value, we can tell that it has been shifted up 2 units. All right, guys, if you have any questions, please be sure to come see me for tutoring.